So welcome back. So now we are moving to the really exciting part of the lecture, because so far we've been storing data, we've been validating data, but we haven't queried data. And querying data is the most beautiful part. And that starts today with MapReduce, aka massive parallel processing. So we're already here, right? Wow, we've done half of it. It's halfway through the semesters, we've done all of that, and now we start looking at that level. Now, I was busy during the weekends hunting Pokemons. The problem is that I caught really a lot of Pokemons. I had hundreds of them. I actually tried to count them, but it took a long time, go through one by one. And then I thought, okay, there must be a better way than counting them one by one. And then I thought, but wait, I have 500 students. I can use this infrastructure, right? So I'm going to do exactly that today, and you can see if you can do better than me. So we need to count these Pokemons. I need to know how many of each I have caught, right? So they're called, I don't know them by heart, like Bulbasaur, Ivysaur, Venusaur, Charmander, Charmeleon, Charizard, and so on, right? Who knows their names? Some of you, right? Okay. So here's what I would like you to do. I need 8 volunteers. You need a pen. 8 volunteers who have a pen. Okay, you can come to the front. I need 8 people. And I will explain what you will do. 8 people. Yeah. You will then go back to your seat. No, you can stay in the front over here. You don't need to come here. So you can take this. That's one. You can go back to your seats with this. Yes. There you go. There you go. There you go. Do we have 8? I have 5 more. Yeah, here you go. Here you go. 3 more. Perfect. You're exactly the right number. 7 and 8. Oh no. Oh yeah, that's 9. You can do the reducing part. So stay. Well, you can go back to your seat, but come back for the reducing part. Come back to it. We'll need more volunteers. So here's the thing. You have many Pokemons that I basically spread to 8 people. So you don't have all of them. You each have a shard or a partition or a chunk or a block. See, here they are again. And what I need you to do is count the Pokemons that you have of each kind, and to count them and to write on the piece of paper that I gave to you, which basically looks like this. For each Pokemon, I need you to write the number, right? And you see it's ready to be separated, but that I'll come back to. Okay? So you need to basically count them. So you can do that while I continue to explain what's going to happen. So now, what happens is that I need other volunteers, and here, this is where you can come back. Yes? No, the nulls are not. You can throw. Oh, no, you can just throw it away. That's when I cut the paper. All right. Okay, so then we need other volunteers, and I actually could use 8 people again. You will all be assigned a Pokemon, one of them. And what you'll have to do is gather from the other people who are now counting the Pokemons. You have to gather all of these pieces of paper, but just for the Pokemon kinds that you're responsible for. Since there's 10 kinds, 8 of you, 6 of you will get 1 Pokemon, and 2 of you will get 2 Pokemons. 4 plus 6, that's 10, yes. All right, so now, do we have 8 volunteers so you can come back? So I'm giving you 2 Pokemon since you were very eager to help. These are the 2. Thank you. All right. 1 or 2? Tell me. Somebody gets 2. So by default, I'm giving 1. There you go. There you go. There you go. There you go. And here you go, these 2. All right? So here's what you're going to do. The people who were in the second round of helping, pay attention, have to sum up the number that you will get from the other people and write it back on your paper as the sum, right? Then at the end, I should get all of my numbers, hopefully faster than what I did alone, right? So now people are mapping, right? So this is the phase that people are counting Pokemons. So what I would like is for you to raise your hands and scream or whatever to basically make me understand that you're done mapping your batch of Pokemons. Is anybody done so far? Nobody's done yet. So we'll wait until people map and the first mapper is done. Even if you're not counting Pokemons, observe what's going on. Look for the bottlenecks of what's going to happen. It's going to take a while, but it's interesting to observe the structure. So now what you observe is that everything is in parallel so far, right? So people are counting Pokemons in parallel. Do we have a question? Yes?
Why do some reduced people have one strip of paper and another have two?
It's just because it's a decoupling. I don't want the number of volunteers to be necessarily the same as the number of Pokemons. In fact, in practice, we often have less volunteers than the number of keys. The Pokemons are basically keys, right? But that I'll come back to when we talk about optimizing the computation. But that's already a good question, right? That observing that the number of volunteers who reduce is not the same as the number of Pokemons. Finished? Somebody finished? Oh, wow, we make progress. I have a progress bar here. Somebody else finished? You finished too? Wow, wonderful. We are making progress. So the people on Zoom can basically follow the progress on the screen, right? So 1, 2. So now you can come back to the front. Everybody who is a reducer, the second batch of volunteers, please come to the front and show your Pokemon like a flag, like this is what you're responsible for. And the mappers who are done, you can come to the front too. You need to shred your piece of paper to separate the Pokemons and give them to the responsible people, right? So you need to come to the front and shred Pokemon by Pokemon, and you just need to give it to the responsible reducers, okay? Think of the algorithmic complexity of what is going on right now. That's called shuffling. Do we have a third mapper? Wow, some progress. You see the progress bar on Zoom. Some people have two, so you need to check. So now we wait patiently. So now we have more people who completed, so we are making progress again. 6 people are done, 7. I see a 7th mapper on their way to the front. Beautiful. So what's going on right now in the lecture hall is also what I call the spaghetti part. The shuffling part, it's the spaghetti part. Because every mapper needs to speak with every reducer. Is there any mapper who is not done yet? Any mapper who is not done? Still counting? Here, over there, where? In the center, yes. So this is also, observe that not everybody is done at the same time. Some people need longer, maybe because they have more Pokemons, can be many explanations. Are you done? Who is this? I can't see it.
It's picking up, so it's second person sitting there. Are you done? No, yeah, okay, he's done.
Yeah, awesome. So you can come and give in the front. Ah, you're already done. You already gave it. Okay. So so now we are shuffling, right? So this is the progress bar is changing colors. So the shuffling is going on. Shuffling, in progress. Still shuffling. Still shuffling. Yeah, wonderful.
Of matching zeros and sixes,
Uh-huh.
confusing them. Come on. You can't carry your map.
Okay. Now you can count them if you have them all. No, you need to add the numbers. Yeah, exactly. You need to make sure, is anybody left? Everybody has given everything? Yeah, we are done with the shuffling. So now you can reduce. So now the progress bar is continuing.
This is my final answer.
Yes, you can bring it here. So once you're done, you can bring me the final numbers and you can throw away the intermediate values. So now the reducing is taking place. One more reduced Pokemon, yes. So I have 52 Charmander, 57 Charizard, 31 or 35? 35 Charmeleons, yes. Awesome. A fourth one, thank you. I have 81 War Turtle. I have, so the intermediate ones you can throw away. 47, did you write it back? Oh, I need the intermediate keys. You can take this one if you want to take it from here. Thank you. So we are making progress. Thank you. I have 6. Yeah. Oh, you can do it. Yeah. All right. 4. I have a rollback here. One of the reducers is rolling back. Thank you. Thank you. So now I have 7 out of 10. 8. 9. Oh, I have 8. 2 missing. We're almost done. Venusaur, Charmander, Charmeleon. I have Blastoise and Pikachu missing. Oh, Blastoise and Pikachu. Wow, we are done. Complete. And we needed 12 minutes. That's better than I did. That's better than I did. So you're great. Thank you very much. Now I have all my Pokemons counted. Thank you. I'm glad you appreciated it. All right, so what you've seen is basically a human MapReduce. So technically, I'm done with the MapReduce lecture. You can go home. No, I'm still going to give you a bit of theory behind this, and we'll continue tomorrow. But there's a number of things that you should have observed. So maybe we can circulate the microphone. Can you make any comments on what you saw? Knowing that it's humans, but we can derive a lot of things that would be going on in a cluster. Maybe can you tell me the bottleneck? Yes, over there. Somebody wants to, over there at the back. We have 5 minutes left. Yeah.
Okay, it's good. Yeah, I mean, there was some bottlenecks. Like some Pokemons were already counted, but other ones were not. So you had to wait on that one. So there was some stalling there.
Yeah.
And also maybe some overhead to wait for the other person to arrive to you and give you the right badge. Exactly.
Yes, absolutely. So this is the idea. What you saw in the middle, the big shuffling, also that I refer to as spaghetti, is indeed the bottleneck. What is the algorithmic complexity of that? Imagine n is the number of both mappers and reducers. Anybody? Algorithmic complexity? N squared, yes, it's quadratic. In big data, we are very scared of quadratic. We love linear. We love O of 1 and log n, of course. We love that. But quadratic, it's not just exponential. Even quadratic, we're afraid of, because this is where the cluster stops parallelizing well. But apart from the quadratic part, you saw that we had a gain of time because the mappers, so the first volunteers, counted in parallel, each their batch, and then the reducers did their counts in parallel. Now, as you also correctly observed, not everybody was done at the same time, right? So some of the mappers were done very quickly. Some others were done with more time. I will also come back to this and how this is addressed. You also might have noticed that the reducers only started counting when they had all of their key value pairs. More exactly, they should have started counting when they had all of them, because if they didn't, they have to update, right? Is it what you wanted to say? Exactly, you added once you got a new one. So this is basically what we can learn from, because you didn't wait for all of them. You had this extra work at the end that you needed to update this. You were lucky because the counting function is associative and commutative. So this is why you could do what you did. If the reducing algorithm wasn't associative or commutative, then you would have had to start all over from scratch with all of your batch. But it's great that basically it happened, because we learned from this, and this is the insights that we get. Any other comments? Yes?
We had the progress bar displayed, but I think it's not that accurate, because we take a lot of time until the first person reports the results, and then there's only a little difference until the last person does. So the progress bar kind of jumps from 0 to 100.
Yes, that's because I'm a human being. So the progress bar, basically on a cluster of machines, you would get something more accurate. You could make it dependent on the, basically on the number of mappers divided by the total number of mappers. Basically, everyone a mapper completes, you can update the progress bar. But what I did was inaccurate in the way that I did it. It was just an approximation of reality, right? Does it address what you said? Yeah, awesome. Yes?
How do we choose the number of mappers?
How do we?
Choose the number of mappers?
I just picked 8 because I wanted to have 8 and 8 so that you could say quadratic instead of n times m. But basically, in practice, there are rules that basically help you choose the number of reducers. I will come back to that in the optimization part. So basically, just so that you already know, the number of mappers should be less than the number of shards that you have. Here I had 1-on-1, but that you saw the problem with 1 per person, that some take longer. In practice, you might have like 3 times or 5 times as many shards as mappers. Now for the reducers, the thing is, it depends on your algorithm, because it depends on the number of intermediate keys that you're going to have. In my case, I had 10 intermediate keys, because that was the Pokemons. So basically what that told me is that I didn't need more than 10 people for the second part. And then the thinking why 8 and not exactly 10 is that in case somebody takes longer for counting, they can have a second one. But that I didn't do because I gave in advance the 2 Pokemons to the people. You can optimize by giving only 1 and keeping the 2 in reserve, and then giving the other 2 after they're done. Then it's dynamic, right? So this is the insight regarding your question. All right, we're almost done with this hour. Any other observation? All right, so I think today we can leave it at that. So think about what you've just seen, either the progress bar on Zoom or the actual Pokemon hunting in the lecture hall. And tomorrow I'll give you all the theory behind this and what it means to do it with machines in a cluster. So thank you very much. See you tomorrow at 9 a.m.